This is section 9.2, graph and write equations of parabolas. Conic sections, or conics, are the figures formed when a plane intersects a double-naped right cone. A double-naped right cone are two cones that are opposite of each other and extend infinitely upward and downward. The four common conic sections that will be covered in this chapter are parabolas, the ellipse, the circle, and the hyperbola. As you can see, you can get a parabola by taking a plane and slanting it and cutting through a double-naped cone where it only touches one of the double-naped cones. If you slant a plane and cut through the double-naped cones and it hits both of the double-naped cones, you will get hyperbola. If you cut one directly across, you will get a circle, and slightly slanted, you will get an ellipse. Now you can also get degenerate conics. That's if you have a plane that cuts it through exactly where they meet, it'll give you a point. If you go at a diagonal so that it goes and just touches both edges of the two cones, you will get a line. Or if you cut it vertically down through the middle, you will have intersecting lines. Now the general form of the equation for conic sections is ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. In these equations, you just can't ever have it where a, b, and c are all equal to 0. So for it to be a conic section, at least one of them still has to be present. Now a locus is a set of all points that fulfill a geometric property. For this section, we're going to be talking about parabolas. So a parabola represents the locus of points in a plane that are equidistant from a fixed point called the focus and a specific line called the directrix. A parabola is symmetric about a line that is perpendicular to the directrix that's called the Axis of Symmetry. And the vertex is the intersection of the parabola and its axis of symmetry. Now, there's going to be two different standard forms of equation for a parabola. Now, the original parabola, or the one that opens vertically, is the one that you're used to. That would be an equation of the form y equals ax squared plus bx plus c. If we write it in standard form, it's going to be x minus h squared. It's still the x part that's squared, is equal to 4p times y minus k, where h and p is your vertex. To find your focus, if the x is squared, you're going to do h and k plus p. The axis of symmetry will be x equals to h, and the directrix will be y is equal to k minus p. If your parabola is opening horizontally, your equation, the y will be squared instead of the x. So in that case, our focus will be h plus p and k. The axis of symmetry will be y equals to k, and the directrix will be x is equal to h minus p. So on this one, we have an equation of x is equal to negative 1/8 y squared. We're going to identify the vertex, the focus, the axis of symmetry, the directrix, and then we're going to graph it. Now we're going to start with that equation first. If you look back at the equations, when the y part is squared, whatever is squared is by itself. So we want to get the y squared by itself on this one. So what we're going to do is we're going to multiply everything by a negative 8, or multiply both sides by a negative 8. So this will give us a negative 8x is equal to y squared. Now, the general form is going to be y minus k and h minus x minus h. So if you want to write this in that form, it would just be x minus 0 and y minus 0 squared. If there's nothing with the x and the y, it just means that you're subtracting 0 from them, which means your vertex will be at 0 and 0 because your h is 0 and your k is 0. Now the part in front of the x is your 4p. So in this case, 4p is equal to negative 8, or p would then equal negative 2. Now, if this opens vertically, if p is positive, it'll open up. If p is negative, it will open down. If it opens horizontally, if P is positive, it will open to the right. If P is negative, it will open to the left. Because it is the y squared, it is going to open horizontally. And because it's negative P, it will open to the left. So we know that our vertex will be H and K. So that's at 0 and 0. Your focus will be H plus P and K. So if I do H, which is 0, plus P, which is negative 2, 0 plus negative 2 gives me negative 2 and 0. Your axis of symmetry will just be y is equal to k, or in this case, y is equal to 0. And our directrix will be x is equal to h minus p, or 0 minus negative 2 will become a positive 2. So our vertex is at 0, 0. Our focus is at negative 2, 0. Our axis of symmetry should always go through our focus and our vertex. And our directrix is a positive 2. You're going to start at your vertex, go towards your focus, away from your directrix, and you want to make it symmetric about your axis of symmetry. So for this one, we're just going to write our equation for our parabola. So if you notice, our vertex is at 0, 0. So that means h is 0 and k is 0. Now they're showing you that we have, this is a scale of 1, so if I go 2 units, it's gone 1. Our directrix, they show you, is down here. So that is 1 1/2. Sorry, it is 1 1/2. We're right there. So our directrix is that y is equal to negative 1.5. Now, because it's y equals for our directrix, we do know that our equation is going to be in the form, if you go back and look at your equations, if your directrix is in the form of y equals something, it is going to be the x that is squared. And it's going to be that x minus h squared is equal to 4 times p y minus k. But we also know that our directrix is going to be k minus p. So if our directrix is negative 1.5, we know our value of k is 0, so we have 0 minus p, or negative 1.5 is equal to negative p, which means that p will equal 1.5. So if we know our h, our k, and our p, we can just plug that into our equation. So it'll be x minus 0 squared is equal to 4 times p, and then multiply that by y minus k. Or if it's just x minus 0, you can leave in that form, or just write it as x squared is equal to 4 times 1.5 is 6, and then y minus 0 just gives you y, so we can leave it in that form. For this given equation, we're going to again identify the vertex, focus, axis of symmetry, and directrix, and then once again graph that parabola. Now, because it is y plus 5 squared, the y is squared, we do know that it is going to open horizontally. First, we're going to find our value of h, and then we're going to find our value of k. Now, h is with the x. When you pull it out of the x, you change the sign. So that's going to tell me that h is 2. K is with the y. Again, when you pull it out of the parentheses, you change the sign. So k is going to equal negative 5. And we know that 4p is equal to negative 12, or in this case, p equals negative 3. So because y is squared, we know it's opening horizontally. Since p is negative, we do know that it will open to the left. Now, let's identify our pieces. We know the vertex is h and k. So this will be at 2 and negative 5. The focus will be h plus p and k. H plus p, or 2 plus negative 3, will give us negative 1 and negative 5. The axis of symmetry, in this case, will just be y is equal to k, or y is equal to negative 5. And again, that axis of symmetry should just go through both the vertex and the focus. And we know that our directrix will be x is equal to h minus p, or 2 minus negative 3, which will give us x is 5. And so we have our directrix. Last thing you need to do is you need to start at your vertex, go towards your focus, away from your directrix, and try to be symmetric about the axis of symmetry. Now this one, again, we're still identifying the vertex, focus, axis of symmetry, and directrix, but in this case, the equation is not in the correct form. To be able to do this, because the x is squared, we do know that it's going to open vertically. But the first thing we're going to do is we're going to rearrange our equation. And we're going to put everything that has an x squared on one side, everything that doesn't have an x squared on the other side. So because the x's are here, we're going to leave those alone. I'm going to move this negative 6 to the other side. So we're going to have y minus 6 is equal to negative 1/4 x squared plus 3x. Now, to be able to graph this, we are going to have to complete the square for the x's so we can figure out what that perfect square is for us to factor it. Perfect square trinomial. But before, if you remember, we can complete the square, you do have to have the x squared by itself. So the first thing we're going to do is we're going to multiply everything by a negative 4 first to get the x by itself. So this is going to give us negative 4y plus 24 is equal to x squared minus 12x. Now to complete the square, we need to find the value of c. And remember, c is equal to b over 2 squared. Your b value is whatever's in front of the x. So in this case, it's going to be a negative 12 over 2 squared. Negative 12 divided by 2 is negative 6. And negative 6 squared gives me 36. So we are going to add and subtract 36. Now, our perfect square trinomial is just this first part. So we don't need that negative 36, but we have to add it because you can't just add a 36. You have to do the positive and negative version. So we're going to take the negative one and move it to the other side by adding it. So this will give us negative 4y plus 60 is equal to y squared minus 12x plus 36. Now, if we go back and we look at the equations, you will see that the y part's by itself, there is just a 4p in front of it. So you do want to factor it out so the y is by itself, and then we are also going to factor the x side. So to get the y by itself, we're going to factor out a negative 4. Negative 4y divided by negative 4 will just leave you with y, and 60 divided by negative 4 will leave you with a negative 15. Now on this side, remember, when you are finding that value, whatever ends up in the square here is also what will end up in the square here. So this is our equation for our parabola. From this equation, we can see that h is equal to 6. K, when we pull it out, change the sign, becomes a positive 15. And if 4p is equal to that negative 4, then p is equal to negative 1. So our vertex will be at 6 and 15. We are going to have to change the scale on that y. We'll change the scale to 2. We'll leave the x alone, but we'll change the y scale. So So we have 6 and 15. Your focus, because it is the x that is squared, your focus will be h and k plus p, or in this case, it'll be 6 and k plus p, or 15 plus negative 1, will give us 14. Our axis of symmetry will be x is equal to h, or x is equal to 6. And our directrix will be y is equal to k minus p, or 15 minus negative 1. We'll turn into 15 plus 1, which will give us y is equal to 16 as our directrix. Again, you're going to start at your vertex, go towards your focus, away from your directrix. Because it was x squared, we do know that it should open vertically, and because our p was negative, we do know that it should be opening down. Now this time they're going to give us two characteristics. We're going to write our equation, and then we're going to graph it. Now they give us our vertex, and we do know our vertex is going to be h and k. Our focus, if you notice, the y values are staying the same, so our focus must have been h plus p and then k. Now from our equations, if your focus is h plus p and k, then the equation was y minus k squared is equal to 4p times x minus h. Now we do know that h is equal to 1, k is equal to negative 4, and we know that h plus p is equal to 3. So 1 plus p is equal to 3, or p is equal to 2. Now we can just take our information and plug it into our equation. So we know that we have y minus k, when you put that in, remember change the sign, is equal to 4 times p. 4 times 2 gives us 8, and then x minus 1. So here's our equation. We already know that our vertex is at 1, negative 4. We know our focus is at 3, negative 4. We know our axis of symmetry will go through our vertex and our focus. The last thing we will have to find then is our directrix. Our directrix, because it's y minus k squared, we do know to be h is equal to x is equal to h minus p, or h minus p will give us a negative 1. So we will start at our vertex, go towards our focus, away from our directrix, and be symmetric about our axis of symmetry. This time they're going to give us our vertex and our directrix. So the vertex again is your h and your k. So we do know that h is equal to negative 2, k is equal to 4. Now our directrix, if it's y equals, it must be in the form of y is equal to k minus p. So we can say 1 is equal to 4 minus p. If we subtract the 4 to the other side, it'll give us negative 3 is equal to negative p, or p is equal to 3. And because our directrix was y equals, we know our equation will be in the form of x minus h squared is equal to 4p times y minus k. And again, we would have found that from the standard form information. So our equation will be x plus 2 squared is equal to 4 times p, which is 12, and y minus 4. Now we just need to graph it. We do know that our vertex is at negative 2 and 4. Our focus, because it is x minus h squared, the x part is squared, we do our focus will be h and k plus p, or in this case it'll be -2 and 4 plus 3, which gives us 7. Our axis of symmetry will be x is equal to h, or x is equal to -2. We already know that our directrix is y is equal to 1. And our graph will start at our vertex, go towards our focus, away from our directrix, and try to be symmetric about the axis of symmetry.